Here are the formulas for the derivatives of the 6 inverse trig functions. For this video, we will derive the derivative of arcsinx. For the derivative with respect to x of sine inverse x, let's start by letting sine inverse x be equal to theta, because the output to an inverse trig function is an angle, and that angle we can represent by theta. By the inverse property here, we can let x equal sine theta by taking sine of each side. Next, let's turn to a right triangle for a setup here on a diagram. For the non-right angle, let's let that be the theta. Since we know sine theta equals x over 1, we can let the opposite side be labeled as x and the hypotenuse as 1. We need to find an expression for the base. I'm going to call it b for now. And by the Pythagorean theorem, which we can apply, b squared plus x squared equals 1 squared. By subtraction, solving for the b here, b squared equals 1 minus x squared. And by the square root property, b will equal square root of 1 minus x squared. I like to label that value or expression for b right next to the triangle. b equals the square root of 1 minus x squared. Next, we have this expression here where x equals sine theta. And we want to take the derivative of that with respect to x. Let me note that over here. If we take the derivative of the left-hand side with respect to x, the derivative of x with respect to x is 1, and the derivative of sine theta with respect to x is cosine theta multiplied by d theta dx. And that's due to the chain rule, since theta is an implicit function in terms of x. Solving for d theta dx here, we can divide each side by cosine theta. We will have 1 over cosine theta. Then turning to the diagram here for cosine theta, d theta dx equals 1 over cosine theta, where we're going to read cosine theta as the adjacent to the hypotenuse, adjacent side to theta being square root of 1 minus x squared, over hypotenuse, which is 1. So that right-hand side I'm going to represent as 1 over square root of 1 minus x squared. And then going back to our original setup here, d theta with respect to x, we just took the derivative of theta with respect to x. So that represents the derivative of sine inverse with respect to x, since those two sides are equivalent. So what we just found here was the derivative with respect to x of sine inverse x. Since sine inverse x was equivalent to theta, that result equals 1 over square root of 1 minus x squared.